And a big g'day to everybody up there in New South Wales in the Harden-Murrumburrah region. It's Graeme Anderson here. I work in extension and seasonal risk with Agriculture Victoria, and I've put a few slides together on your local climate for a climate champion who lives up your way. And first up, I'm just going to give a bit of a plug for the Climate tool. It's a great tool for Australian farmers. There's for the address you can get it from. You can put it on your phone or on your computer, but you can download your local rainfall history and do all sorts of queries with it. I've just done that with Harden and looked at the rainfall the last 6 months. Here's actual rainfall for the last 6 months versus that's the average, and then this is the whole range of either wetter or dry years. But certainly you can see you're certainly a fair way behind the 8 ball for the last 6 months, and hoping that that improves soon. Now what we've got here is a long-term rainfall record for Murrumburrah Harden. Goes all the way back to 1885 right through to 2017, and up the left axis here you've got millimeters of rainfall, and there's just this is an anomaly graph, so there's a line put right through the middle which is a long-term average of 609 millimeters. So you can see lots of variability there. Some years you get over 1,000 mils and other years barely make it to 300. And of the last 20 years you've got 13 drier and 7 wetter, so probably batting a bit below average. And we'll talk about what's behind some of these wetter years. You can see this is 2016, which the Indian Ocean dipole had a role in, the big 2010 La Nina, extra moisture from the Pacific, but also sort of dry years of the El Nino of 2006, 82, then 67. So we'll run through some of those things about what's behind some of those big wetter and dry years in your part of the world. And here's that same rainfall record, but it's just split into the 4 seasons, and you can see between summer, autumn, winter and spring there's not a huge variation in rainfall. It's fairly evenly distributed, and while in each of them the last 20 years there's been a couple of extra dry years thrown in, there's no strong trend in any of them. Now, to make rainfall, we need 2 key ingredients. First off, we really need a good source of moisture, and for us that source of moisture comes from these warm oceans to our north. And we've got the Pacific Ocean and the El Nino Southern Oscillation. Trade winds blow towards Australia and is a good sort of source of moisture. We've also got the Indian Ocean dipole that feeds in moisture as well. Now, in some years we're getting extra supply of moisture. So the 2010 wet year, you had heaps of moisture coming out of this with the big La Nina, and the Indian Ocean dipole was also, both of those oceans were sending heaps of moisture that year. If you look at a year like 2006, El Nino in the Pacific, so the trade winds going backwards, there's less moisture getting to us from this part of the world. And also the same year in 06, the IOD was in its drier phase. So these oceans play a really important role in terms of that source of moisture. But the other key thing to sort of wetter or dry years is not just about having moisture, but it's also the number of rainfall triggers or disturbances which come through. And when you look at around the southern ocean here, you can see there's a big conveyor belt called Southern Annular Mode, which really you can see all of those cold fronts and disturbances which sweep across a lot of southern Australia. And so some years we get a lot more triggers of rainfall than others, and those wetter years are when we've got plenty of triggers coming through and plenty of moisture coming in from up north. So we'll talk a little bit about how these two affect your local part of the world. Also, just an example here, this is a sea surface temperature map. Now the ocean along the equator is always a lot warmer. Up here it's like a warm bath, and it's pretty cold down here around Antarctica. But this is an anomaly graph, so it's just comparing the temperature compared to normal, and these yellow orangey colors are where the ocean's a bit warmer than normal, and these blue colors are where the ocean's a bit cooler. Now we've gone here back to September 2006, and this is what a dry pattern looks like for southeastern Australia. We've got an El Nino in the Pacific, lots of warm water there, and you'll notice all of this cooler water to our north, and the same in the Indian Ocean, the warmer waters over near Africa, cooler water here out off Sumatra. So when that sort of pattern happens, the extra cloud and moisture is always over the warmest water. So in this situation there'd be extra cloud over here, floods in parts of South America. But what we've got here is clear skies, cooler water and clear skies, less moisture to our north, and that means there's less moisture to feed into our rain events. So that's a dry looking pattern. Now have a look at this area when we compare it to a wetter pattern such as say the spring of 2010. So you might notice a bit of a difference there. So here we are, October 2010, got a big La Nina in the Pacific, lots of really warm water pushed up around us, and there's moisture and cloud galore to feed into our weather patterns. This really warm area here for the Indian Ocean, so really wet year. Then it's up to individual weather events as to whose farm that moisture falls out on, but certainly that's what the wet phase looks like. Now, usually when we look back through historical rainfall, we can just easily say a third of the years were dry, a third average, and a third wet. Now, what we're going to do is look at that Murrumburrah Harden and just see, did this ratio of dry or wetter years change when we had the Pacific or Indian Ocean in one of its drier or wetter phases? And here we go. So here's an El Nino year. The typical pattern in El Nino years is a bit drier and less moisture coming in from the eastern part of Australia. When we look at the 32 El Nino years in that long-term rainfall record for Murrumburrah and Harden, what we get is, instead of a third of those years being decile 1 to 3 or dry, actually double the number of, so 2 out of 3 of those years were dry. So that's pretty important, doubles the chance of a dry spring. And I'm talking about August, November rainfalls here for that record. So it does increase the chance of dry, but what's important is that when you notice that when there's been an El Nino, not all of them have been dry. There's actually a third of years that have been average or even a bit wetter. So certainly changes the odds, but doesn't guarantee dry. When we look at La Nina years, you can see extra moisture over a lot of parts of Australia in La Nina years. August to November, when we look at Murrumburrah Harden, again, doubles the chance of a wet year. So with those 32 La Nina events, instead of a third of them being wet, 2/3 of them are wet, but you can still see, doesn't guarantee it. There was the odd one that was dry or average there too. And for the Indian Ocean dipole, you can sort of see this is the part of Australia that was a bit drier when it's sending less moisture. And the main sort of signal there in your part of the world is just that it really reduces the chance of a wetter year. When the Indian Ocean's in its wetter phase, like it was in 2016, it's again a good source of moisture, increases the chance of being in that decile 8 to 10 and reduces the chance of a bit drier. So all important drivers for your long-term variability. So one of the things is there anything happening now that's not just a part of good old-fashioned variability? And one of the main things I point to is temperatures. So here we've got temperatures for New South Wales for the last 100 years. That's summer, autumn, winter, and spring temperatures. So a lot of variability there, but you'll certainly see in the last decade or two there's been a lot more years warmer. And the Bureau really described this as like squeezing in an extra month of summer. And you can sort of see here for summer months, some of those summers have been 1, 2, or even up to 3 degrees warmer. So while we might have long-term rainfall variability, over the top of this is now this sort of warmer pattern. And have a look at that recent autumn you've just had, the hottest autumn on record, over 2.5 degrees warmer than long-term average. And look at these springs. When you look at the last 10 springs, there's only been 2 that have been a bit cooler, and they happen to coincide with those sort of wetter years when there's more cloud around. But most of the springs have been between 1, 2, and up to 3 degrees warmer. So that's really almost a month out of whack. So that puts a lot of pressure on our pasture production and crops if we're getting that sort of summer coming a month earlier. And just looking at the last 6 months in terms of max temperature deciles for Australia, you can certainly see that it's actually been warmest on record for max temps in the last 6 months in the part of the world. And also just down here, what we've got here is for New South Wales, it's the percentage of area of New South Wales that's in decile 10 during spring, and you can see that long-term record there for the last 100 years, but certainly that decile 10 during spring is happening a lot more often, or a lot more proportion of New South Wales being impacted by that. So that doesn't really look like just natural variability. And another thing that's a bit different at the moment is the pressure pattern that sits over our heads. This is the pressure right across southern Australia. This shows from 1950 through to 2016, and you can see the pressure pattern just varies from year to year. This is April to October pressure, but you can certainly see there a bit of a trend line which goes up, and it's usually higher in those El Nino years. But one of the key things is that as things have been getting warmer, this pressure pattern gets stronger, and it's all to do with the subtropical ridge, and you can sort of see that pattern there. So it's what the climate scientists expected to happen as things got a bit warmer, and it's in a lot of the climate change models in terms of why, when they run those models into the future, why some of southern Australia has less rainfall. It's just because of this increasing pressure pattern and squeezes out a few rain events each year. Now, small changes in annual rainfall can mean to much bigger changes in water runoff. This is a Bureau catchment reference station from an undisturbed catchment. You can see here from Adelon Creek, Batlow Road, and you can see here that the annual flow rate since 1950 took a bit of a step change there in the mid-90s and hasn't quite recovered. Now, a key issue for catchment is that for some, the relationship between rainfall and runoff can change, especially if we get a longer run of dry than average years, and things like the upper catchment base flows are a bit less reliable. So the end result is that improving farm and regional water security is going to become more important in future. And this is another aspect of seasonality for rainfall. David Stevens with AGIC recently analysed when rain fell in the period since 2000 and compared that to the previous 100 years. And he found that our seasons had shifted south, and with climate change and rising temperatures, this is a useful way of how to look at our climate zones as they might shift south over coming decades, and which will require changes to our farming systems. I guess the good news is that there is profitable agriculture occurring in all of our climate zones, but the key challenge will be about how we adapt and stay profitable amidst these sort of changes. And what we've sort of seen is largely some of those sort of summer and uniform or winter rainfall zones, all of them have slipped a bit further south. So in terms of tackling variability and change, here's a list of some of the key ingredients for successful agriculture. I guess we're going to need a constant flow of new technologies and R&D, genetics and innovations to get better at what we do. Also improved infrastructure both on farms and regionally, and things like water and fodder storage, communications, logistics, transport, and social infrastructure. So we've got what we need to be well set up for the future. Also, growth in markets is a good thing, and it's critical to maintain our competitiveness, but as an exporting nation, making sure we've got our biosecurity and top notch to keep those markets open is going to be really important, and we've got to be careful of not taking any shortcuts when times do get tough. Farms and managing variability, the ones that do it really well are really good at business management, making wise decisions in the good years, strategic decisions that sets them up for when the going does get tougher, when those tougher seasons arrive. So, and with both market and climate volatility, this business management just becomes more important than ever. These days, too, farmers and land care are doing a much better job at protecting their soils and land assets to ensure good pasture cover and using stock management and containment, ensuring no damage to paddocks in those tough years, and things are ready to go when it does rain again. And most importantly, it's all about people. Surround yourself with good people and networks, stay connected, and have good knowledge channels and advice that will provide you with the support and coaching you need to get where you want to. And while agriculture's got a bright future, it doesn't always mean that there's a bright future is guaranteed for everyone involved in farming today. So it's always important to make sure you surround yourself with good people and make decisions that are right for you and your situation. And I like to think about the big 5 questions. You know, are you enjoying what you're doing? Is your family supportive? Are you living the lifestyle you want to? And will you have enough to retire on? And can you sustain the effort? It's important to look after yourself and make sure that you take hold of that steering wheel so you're working towards a better future no matter what you're doing. So that's it. I hope that was of some use. If you want to know any more about these big climate drivers, check out the Climate Dogs. They're on the Climate Kelpie website, and I hope that you can snag a decent rainfall event up there soon. All the best.